Hey, we've always been told that light is a wave, but why should we believe that?
I can answer that. So light shows properties very similar to those shown by waves. They are interference and diffraction.
This is due to the fact that waves superimpose, and this principle is called the principle of superposition. What happens is, when two waves meet each other, their amplitudes either add up or cancel out, depending upon their phase differences. To make my point more clear, let's assume there are two waves which are in phase with each other. When they add up in space, they result into a wave of larger amplitude. But on the other hand, if the same wave add in such a way that they have opposite phases, then it results into a wave which has zero amplitude.
But what is diffraction?
Hi. So, diffraction is a property of waves due to which it can bend around the corner of an obstacle. For example, right now you can hear me because you are in my line of sight. What happens if I go behind this wall? You surely still can hear me because the sound waves are bending around the corner of the pillar and reaching the recorder. So this was diffraction of sound. Now let's go to our main topic, which is diffraction of light waves.
To understand how diffraction happens in light, we must understand how light waves propagate. The wave theory of light was given to us by Christian Huygens. This theory wonderfully explains the incredible phenomenon of diffraction.
According to Huygens' principle, all the points on a wavefront can be considered as the source of secondary wavelets which travel in the forward direction with the speed of light. Now, the angle of all these secondary wavelets gives you the new wavefront.
Alright, now let's focus on this part of the wavefront. Consider some points on it. Now, according to Huygens' theory, these points are the source of secondary wavelets. These secondary wavelets propagate forward at the speed of light. The envelope of all these wavelets give us the next wavefront.
Theory is only good if it explains the experimental results. So let us look at an experiment now. What happens when light passes through a slit?
Consider a source of light from which light is emerging and moving towards the slit. When the wavefront hits the slit, consider these points on the wavefront. These are the sources of secondary wavelets, and they give us the next wavefront. Light from various points on the slit superpose on the screen, giving us the diffraction pattern.
Here we have a red laser and here is a variable slit. Let us see what happens when the laser light passes through the slit.
What you are seeing here is the diffraction pattern of light.
Changing the slit size changes the pattern. As the slit becomes thinner and thinner, the pattern will grow wider and wider. And the same is true if it's done in reverse.
I hope this video helped you understand what diffraction is and why do we say that light is a wave. Thanks for watching the video. वेव करना As computer